I'll start by basically acknowledging the volunteers across the United States, hundreds of volunteers who I've never met, most of them, who help make these events possible. They help people do the critical thinking and troubleshooting and disassembly of their broken stuff. So, you know, we've had this amazing run in consumer electronics. When you think about something like this photograph of the early microwave oven, in the 1960s, the only person with a microwave oven in their house was the chairman of the Litton Corporation, and he used it to impress his guests with how quickly he could cook the food in the house. And now, Amazon, in the last 3 months, has announced a microwave that talks. You can talk to it. That's amazing, and it's $59. We've done this wonderful thing where we sort of created this wonderful group of appliances, and we've concentrated, we've merged electronics and household appliances together to create all these wonderful new devices. And our marketing departments have done a great job of creating the want and needed desire for all of these new devices, okay? You can now get a space heater that rotates and has a remote control. Or you can get an electric toothbrush that lets you, has a built-in timer and oscillating controls, all sorts of wonderful stuff. But what happens when it breaks? It might still be under warranty. The manufacturer will give you another one. But there's a sense that maybe you liked the one that you had. And maybe you'd like to try to understand why it broke to begin with. And then there's this idea that the manufacturer gives you another one, but then you're still left with this one that may or may not be fixable. You just don't know. You're curious about why that is. So that's where Fixit Clinic comes in. And we're also trying to avoid this, okay? There is this sense that we're all starting to understand that the way that we've been practicing consumption up to this point on the planet is unsustainable going forward. A lot of this stuff might have been easily fixable. A lot of this stuff might have even worked, and just people got tired of it. They didn't want it anymore for some reason or another. There are other reasons why you might want to fix something. It might not be available anymore. For the picture on the left, that was a Mixmaster that belonged to her father. It had sentimental value to her. She wanted it working again. And for those of you who have children, you know that the toy industry is kind of like the fashion industry. That if a child has a favorite toy and it breaks, you might not be able to buy another one. That, I don't think that Spider-Man walkie-talkies are going to be an acceptable substitute for the Princess walkie-talkies that this child has. So that's why we hold Fixit Clinics, among the many reasons. And what we do is we have these community pop-up events. People bring in their broken consumer electronics and household appliances. We put them together to try and fix them. This is my one video. This is what it looks like when it's running. So this one is in a library. We ask people to tell us the story. We never short-circuit the end user's story about why the item broke or how it broke, because that often gives us the hint to fix it. What else? We have one rule, which is carry in only, no oversized items. We don't want someone trying to bring a washing machine or a dishwasher into a Fixit Clinic to fix it. We have no way to diagnose it. We have no way to sort of put it together to see that we can recreate the problem. So it's all ages, all experience levels. At an ideal Fixit Clinic, everyone's just helping everybody else out to fix stuff. Here's one of our larger events. We had 150 people come to this Fixit Clinic. And so it's hands-on. This is a laptop where the display was flickering, and we're all working together. We have the volunteer Fixit coaches who work with the owner of the item to try and do the troubleshooting and figure out what's wrong with it. And at some level, the repair is actually a serendipitous side effect of the whole thing. What we're really trying to do is convey this kind of critical thinking skills to the general public so that everyone's fixing all the time, whether there's a Fixit Clinic or not. Another reason why we have people do their own repair is because we're transferring knowledge. We're hoping that people will do this stuff and understand. Once they fix it themselves, then they know they can open it up again and fix it if it breaks again. And hopefully they'll tell their neighbors and friends how to do that. So I'm always joking. We see a lot of toasters, and people, I always say, well, did you bring bread so we can test it after we fix it? And so at this particular event, while the wife was fixing the toaster, the husband went out and bought some bread at the supermarket so that we could confirm that, yes, indeed, the toaster did work. It's community building as well. People from all walks of life come to these. We group people together to fix things that are like things, so in this case, 3 radios. We love it when families come. We love the intergenerational learning. There's this sense that people used to fix a lot more than they fix now, and so maybe these people's parents fixed, and they want to transfer that knowledge to their children, and we always like to support that. Here's another one with a whole family diving in to repair a toaster. And surprisingly, kids younger than you would think are showing a lot of acumen in the ability to repair. In this case, he's replacing the display on iPod Touch. This is an older teenager repairing a Samsung phone for a younger teenager. They had to do a board repair. This is a 7th grader who's fixing smartphones. So this is very possible. We hold a lot of Fixit clinics at the major colleges and universities because the next generation of designers and engineers see this as a great opportunity to see how design for manufacturing occurs now. So they get to open up things that the general public brings, they get to see how they're going bad, and they get to then use that to hopefully inform them in the future. So we are trying with this effort to make sure that the next generation of designers and engineers knows how to design for durability, maintainability, serviceability, repairability from the get-go. We've got one at Harvard in 2 weeks. Okay, so how do you do this? All right, modern consumer electronics are really complicated. And remember, we're doing this without access to manufacturer service manuals. We're doing this without access to any sort of repair parts or schematics or anything. How do you even begin to take apart? How do you begin to take this apart? So the first thing is, obviously, you try and research the problem on the internet. And with certain devices that have been around a long time, you're lucky. There's a long tail of information on the internet about how to address the kind of problem that you might be facing at that moment. This is this kind of KitchenAid mixer. This design has pretty much been around for about 20 or 30 years, and everybody knows how to fix them. And there's exploded diagrams. There's a deep well of spare parts available. We're usually pretty successful with something like this if we have the background information. All right, I'm going to go into some specific things right now that we see. So we see a lot of toasters. Okay, can you guys see what's wrong with this toaster? The element, the nichrome wire on the element is broken. Okay, what do you think happened here? Probably someone was trying to get out a piece of bread. They put a fork or a knife in it. They broke the nichrome wire. Okay, in this case, we can fix it. We have wire crimps. So you recrimp the 2 connections back together, works. But you also speak to the idea that we see this a lot. So in all the years that we've been building toasters, how do we get back to the manufacturers to say, this is a common failure mode, that the customer, the user is going to stick a fork or a knife into the toaster at some point. How do you fix it? How do you address that going forward? So we'd love to get this kind of information back. Okay, here's another toaster, breaking the nichrome wire. But this time, it's deep in the toaster. It's way down in a place where a customer couldn't, or a user couldn't have put a fork there. It's there. So in this situation, it looks to us like it's a manufacturing defect. It looks as if the nichrome wire was bent too quickly around that attachment point, and it caused it to fail and break at that place. Okay, so we'd love to understand, how many toasters were made with this defect? Is this the only one? Was it a whole production run of these toasters? Is it still going on today on a regular basis? We don't really know. But we'd love to be able to get that information back to people. Okay. This is very common. Batteries leak in battery compartments. And a lot of people see this and just think, oh, it's ruined, I have to throw it out. But if you clean it up with steel wool and vinegar, you can make it bright and shiny like it is on the right-hand side again. Another thing, if it's so badly corroded that the metal has actually worn away, you can use aluminum foil and or take a paper clip and fashion some sort of new way to establish connectivity with the battery. In this case, she did everything right. She bought the new battery for the phone, for the iPod Touch, but it's deep inside the device. It's really hard to get to it, and once you get to it, it's glued in. And a battery is something that's a fairly common thing that goes bad. So we should be able to replace batteries more easily than we had to when we did this fix. Laptop displays, sometimes we can get the display for a reasonable price, sometimes we can't. It's a reasonable, high-value item that you'd like to be able to replace the screen on, and we do it on a regular basis. Optical drives. 90% of the time, the problem is that somebody put a fingerprint, and there's some sort of dirt or debris on the lens. So you use a Q-tip with alcohol, clean that off, you're good to go. If that doesn't fix it, the next thing is that it gets stuck in this motorized track and won't move back and forth. So just nudge that a little bit inside the track, works again. Multi-changers, disk optical drives are a different problem. These things are very complicated and fiddly, and they come in many different versions. So often we just really can't do much with these. It's possible some little plastic piece broke off inside or something. When we see these, we struggle. Sometimes we're successful, sometimes we're not. There's no regular way to know. Okay, let's look at some other things that go on. This is pretty obviously old age, okay? This wire is probably 50 years old. That's reasonable expectation for end of life for that. And if you just replace the wire, you're fine. This wire was chewed by a cat. So that's damage. So there's really not much you can do about that. I'm not saying that we should get armored cable for all sorts of household wires just because a cat chews through it every now and then. Replace that, it works. These people came in and said, our microwave makes a bad smell when we use it. And I'm looking at them and I'm going, that's amazing that they didn't see. So they brought the whole thing like that in, and I'll have a blow up. They had no idea that the plug was basically melting away into the extension cord. So just that sort of observational technique to look at things like that. Okay. Lamps. We rewire a lot of lamps. And the lesson to be told here is that the nice thing about lamps is that they haven't been a standard for a good 75 years. The standard's enforced by the threading, the bulb size and the bulb threading, this is the US standard for bulb size and threading. And what this allows is that you have both backward compatibility and upgradability. Okay, so as we've moved through technologies, as we've moved from incandescent lamps, incandescent bulbs, to compact fluorescent bulbs, to LED bulbs, and now we have smart LED bulbs, that all of them will be backward compatible with all the lamps of this type that have been built in the last 75 years. That's great. That speaks to really sort of a great, think about sort of how standards enforce that kind of timelessness to a device. Okay, US plugs are designed in a way that people don't pull them from the plug, they pull them from the wire. So we see this all the time, and wires should be better reinforced at the places people are going to use them. If we're thinking about being of user-centric design and thinking about how the user is going to use your item, when we sell an extension cord, we should think about making it more durable at this point. Here's another one where it failed, obviously not enough reinforcement, but so bad we could actually visually see that the wire had gone bad. This one, we couldn't tell. We actually opened the toaster 3 or 4 times trying to figure out what was wrong with it and why we couldn't get power to it before we finally did figure out that it was the plug. So is there something we can do about this? Well, this is a plug I've seen that I like a lot. Okay? If you think about sort of user-centric design, this plug is super well reinforced. It comes out at an angle, so it discourages you from pulling it out from the cord. And it has these nice little finger grips so that you can pull it out. It encourages you to do the right thing. Headphone wires are really too small. We use them all the time. They don't just break at the earbuds themselves, but they also break somewhere in the headphones. I have a pair of mine that I liked. it was durable wire, but it still failed at the end here. But rather than try and do this kind of difficult fiddly soldering job, I basically just hot glued the end of it in a way that would secure it so that it would always work. So you can come up and look at this later. Microwave ovens. So it's rarely the magnetron or the transformers or the big capacitor that goes bad. What goes bad are the safety interlock switches. So in the door, there are a bunch of these switches, normally open, normally closed, but they're trying to guarantee that the door of the microwave is closed, fully closed, so that the microwave energy doesn't leak out. These switches go bad. A lot of current goes through these switches. And when they do, the microwave won't work anymore. So I talked about that idea that we never let the person, we let the person's story, we let them tell it. They will tell us, well, for a long time I could make the microwave work by holding the door in the corner. That tells us everything we need to know. So the other nice thing is this part, this subcomponent is well documented. Okay, look at all the documentation on that part. So we can go to eBay, look up those numbers, order another one, get the microwave working again. So you have a $200, $300 device that would otherwise be thrown away because of a $5 part. Here's a printer. Look what's happened. The USB jack has come out from the actual circuit board inside. So what can we do here? So if this little USB jack had documentation like that switch I just showed, maybe we could order another one to try and re-secure it to the board. But there are hundreds or thousands of these different types of USB jacks. That's really hard. It's hard to figure out which one that is. And so in this particular case, what we told the person, luckily there was Ethernet and there was Wi-Fi. We told them to use Wi-Fi. Okay, here's another situation. This is a Bluetooth speaker. And the USB 3 port, sorry, the micro USB port has come off the surface mount. It's lost from the pads. It may be broken too. Once again, there are hundreds or thousands of different types of these. We can't order another one, and even if we could order another one, we can't solder it back at the moment onto the pads on this board. Now, on the good side, they did make it into a daughter board. They made it into a separate auxiliary board where all the ports, all the parts they thought human beings would connect to, are there. And I brought a couple more of these as examples. That you can see later of other devices, which this is good design to basically have this sort of a daughter board type of thing set up so that you know the places where human beings are going to interact with it. Those are small and easily replaceable. Okay, I'm going to go through 3 major failure modes of a bunch of consumer electronics, and just as examples. There are more, but I just chose 3 for this. So here's space heater. And when you open it up, there's a thermal fuse inside. And the thermal fuse is designed to break if basically the heater gets above a certain temperature. So that goes bad. You replace it, starts working again. So this is in there because it's trying to make sure that the space heater doesn't make the whole house catch on fire. And sure enough, what this guy admitted to was that he had some curtains near the space heater, and when the space heater was running, the curtains restricted the airflow, so the air inside the space heater went up in temperature, triggered the thermal fuse. Okay, so he made this mistake. Does that mean that the space heater should never work again? That he has to open it up and understand there's a thermal fuse inside? Coffee maker. It doesn't work. So take it apart. There's a heating element in the bottom there, that horseshoe-shaped piece there. Thermal fuse. Okay, we had cut it. We were about to replace it, but I said, let's take a picture of it first. So you replace it, works again. What caused this thermal fuse to fail? I don't know. But somehow it thought it was too hot and it stopped. This is a rice cooker. On the bottom of a rice cooker, there's this metal disc. When you put down the rice container, there's a metal disc in the middle. At the top of that metal disc, thermal fuse. So if we could just figure out some way not to have these thermal fuses go, and they're not just in those sorts of devices. So there's the resistive element heating devices like those. There's the space heaters, the hot water makers, there's the coffee makers, there's the griddles, there's the waffle makers, but they're also in small motor appliances. So deep inside this coffee grinder, there's a motor, and deep nestled in next to the motor windings is a thermal fuse. It's very hard to get to, but that's the reason why, and in this case, the person was trying to grind chocolate, and the chocolate was really gummy, so it caused the motor to bind up, and that's why it overheated. But why should a one-time thermal fuse blow and make the device inoperable? So, some hair dryers and space heaters have a resettable thermal fuse, and I brought one, and you can look at it later. In here, there's a resettable thermal fuse. I think all devices should have that as an alternative. You should not use a one-time thermal fuse. You should use a resettable one. So it's basically a bimetallic element. When it gets too hot, it pulls away, shuts down the device. You leave the device alone for 10 or 15 minutes, it cools off, restores connectivity. Okay, so that class of resistive element heating devices, the heaters, the hot water makers, the toasters, same class of items, different problem. Problem number 2. An electric hot water maker where the button won't stay down. Okay, or a toaster where the toaster button won't stay down. Very common problem. So before we go on to what that problem is, first thing is, when you try to open it up, there's special screws inside. It's either using triangle head screws or security torque screws. They're not using common Phillips screws. This is just a common household consumer appliance. Why make it difficult? Why use a special fastener to keep the thing together? Okay, so here's the problem. These tabs here, there are these 2 contact points. And if they're not touching perfectly, they tend to arc over time. Here's another example here and here. Hopefully you can see it. So when you press that button down, those 2 contact points come together, and all the current going to the heating element goes through those contact points. And so if they're not perfectly aligned, over time they arc. And as arcing over time, they build up carbon, and then they start to fail. And you get to a point finally where they can't draw any current through it, and it just gives out. And that causes the device to fail. We should figure out how to make this device better. We should make it so that the tolerances in this are a little better so that this happens much less frequently than it seems to happen now. The final one, electrolytic capacitors. Okay. These fail everywhere. They're the worst. And they're just really hard to troubleshoot, especially if you don't have a schematic. You can't test them in circuit. And there's something about the way these are manufactured, and they just go bad. And there was a whole generation of TVs from a famous manufacturer. Every TV from the 24-inch to the 80-inch had power supplies where the capacitors were failing, and it would kill the entire TV because the power supply was bad. All right. So we have one thing we can do at Fixit Clinic at the moment, which is we look for visual inspection. A bad capacitor is going to get puffy on the top. So on this device, look to the left-hand side, that board on the left, and then look below the yellow transformer. Right there, that capacitor is puffy. We replace that capacitor, works. Here's some more examples of puffy capacitors. Those 2 are bad, that one's bad. That one's bad, those 2 are bad. So with visual inspection, lots of times we're lucky and we're able to get the capacitors, fix something like that. But I don't know, something's not right with where we're getting for you guys. Can you go back to your suppliers of these electrolytic capacitors and ask them if they can do better quality control? Can we do something that makes these things more, so that they have a much, much lower failure rate than they do now? And the other thing to think about is, what the answer was for those TV sets, for example, was the engineers decided that a 15-volt capacitor was good enough, but the user groups in the internet were saying replace them with 25 volt. So if you had a 470 microfarad 15-volt capacitor, replace it with a 470 microfarad 25-volt capacitor. So for those of you designing things today in the absence of better capacitors, I would say over-spec your capacitors. Put in a higher voltage rated capacitor than the one you were going to put in. Okay. And then the final thing is, how do we design circuits that don't need these darn things at all? How do we basically engineer out the electrolytic capacitor out of everything that we choose to build going forward? Okay, so now I'm going to give 3 examples of manufacturers behaving badly. Right? Printer manufacturers do all these things. Their model, their business model, is to sell you the printer cheap and then make money on the ink. And so it's in their interest to have you buy as much ink as possible. And from what I can tell at this point, the diagnostics are so terrible that when you try to fix a printer, all you're doing is buying cartridges after cartridges to try and fix it. So just the diagnostics are terrible. Unless we're lucky and there's a piece of paper in the paper path or something very obvious, it's really very, very hard to fix these things. And so what I recommend is try and choose the printer manufacturers who allow for a third-party ecosystem of inks and cartridges and toner and stuff around their devices. It's hard enough to fix an iPhone. Why does Apple have to create yet another proprietary screw so that you can't get inside the phone? Okay, this is totally nuts. And so as things become more a combination of hardware and software, we're getting this issue going now where it's not just about the fact that they're trying to lock down the hardware, but for all of us now, Apple, for example, stopped supporting the iPhone 5 and the iPhone 6 with, iPhone 4 and iPhone 5 with security updates. That means that anyone who wants to keep using an iPhone 4 or an iPhone 5 is going to be vulnerable to basically, their personal information could be vulnerable. They could basically be in a situation where their phone could get taken over to be some sort of zombie spam bot on the internet. So there just speaks to this whole nature of ownership. What does it mean to own something? You bought it, you use it. Shouldn't you, if you own it, shouldn't you have a right to upgrade it or to fix it from both a hardware and a software perspective? If some third party wanted to come out with a version of the iOS operating system that applied all the latest security patches, you can't load it onto your iPhone 4 or iPhone 5 because Apple has locked the bootloader. There's no way to get to use the phone, okay? The phone is going to be end of life slowly because Apple wants it to, not because you want it to. Okay, final example of manufacturers behaving badly. This is the famous Xbox 360 red ring of death. Does anybody know about this problem? So basically they had an issue where the graphics chip on the Xbox 360s, something was wrong with the way it was attached to the motherboard. The only way to fix it was to open up the machine and put a heat gun, shield the one part, shield the rest of the components so that you wouldn't damage them. Take a heat gun like you would use to scrape paint, blast the heck out of it, and reflow the solder underneath the graphics chip. So the community found out about this, and the community was saying this is the way you fix it. Apple for a long time denied there was a problem. And basically what happened over time, they finally fessed up. They added a 3-year warranty to the Xbox 360. They fixed a lot of them. I got one fixed by them this way. But how many people in the interim ended up throwing it away or not being paid for professional repair or something like that for a device that was just basically a lemon? All right, so this is my one text slide. Sums up everything I've said so far. Okay, support and use standards. Reveal your sourcing. Let us know where those little tiny parts come from so we can replace them when they break. Okay. Support repair documentation, whether it comes from your factory, from your engineers, or it comes from the user community. Okay. Help create service manuals so that people can really own your stuff. All right. Batteries should be easily replaceable. Don't use glues or adhesives. Okay. Design away from those one-time thermal fuses. I've got some examples here if you want to see what these thermal fuses look like. Put in resettable thermal fuses. Okay. Better quality control overall on electrolytic capacitors. Wires should have modular connections on all the ends. Use standard connective tools, standard screws. Don't use fancy screws. Make any ports or places where ports come in be heavily reinforced and easily replaceable. Okay, eschew the razor blade business model. Don't try to sell people the inks just because that's where you make your money. And be open and honest with your customers. So I showed this slide before about a lot of people basically understand that what we're doing on the planet now is unsustainable. We've got to slow down this churn process. We've got to keep things at their highest utility possible for as long as possible. And there's this idea of repair as being this revolutionary act, this militant act. But this old photograph of nuns doing radio repair shows that this is fairly common. And there are whole industries, there are whole places where we expect to be able to do our own repair. Farmers have always done their own repair. It's part of being, it's part of being a resilient society and being able to sort of be able to fix stuff yourself, understand it enough to fix it. But the modern John Deere tractor is sold to you. If you're an American farmer, you have to sign a service agreement that only John Deere can service it. It's such a combination of hardware and software that at this point they're nervous that they don't want you to get access to their proprietary software, and they're just basically saying the only way to fix it is to come to us. And in a modern society, with all this technology, we need to figure out how to address that. I mean, for this person, maybe, yes, their family photos are on this computer, but maybe their access to banking is on this computer. Maybe their Bitcoin is on this computer. There's a way in which these things are permeating our lives that we need the kind of tech literacy that Fixit Clinic conveys on all aspects of it. This stuff is going to the landfill prematurely because all these smartphones have so much wonderful capability in them, okay? They've got a touch screen, they've got GPS, they've got a USB port, they've got all these wonderful things that could be repurposed in other ways rather than just throwing them away. This is another thing that's coming down the pike. Okay? So lithium-ion batteries are only now becoming a small part of the waste stream. But when they are thrown away, if they get damaged, they can go into thermal runaway and combust. All right, here's a great video. So what's happening now is that all over the United States, and probably in your countries too, in garbage facilities, all of a sudden they're having these fires, in the garbage trucks and in the garbage facilities because these batteries are in there and they're getting crushed. Here's an example. This is it's a bigger lithium-ion battery than one in a cell phone, but you get the idea. That this is a major problem. In the United States, we've had 2 major fires already. One cost $40 million, one cost $8 million. And more than the cost, the insurance underwriter said, we're not giving you insurance again. So people's waste collection is going to be at risk. So that's why legislation is moving forward in the United States to have right to repair. This idea that there should be some basic rights that we should have in order to repair our own stuff. We bought it, we own it, and it's different from state to state. It hasn't passed anywhere yet. Apple and John Deere are fighting it like mad, but that's sort of the trend. That's the underlying environment under which this is happening. And so I'm going to leave you with a positive note, which is this idea that I talked about surface mount soldering before. We're not doing it yet, but we're starting to. There's a broader trend going on now because of what's happening with this democratization of high-tech machining. The kinds of machining capability that used to be the purview of military defense contractors only. The milling machines. Everyone makes a big deal out of the 3D printers. But I'm talking about the milling machines and the PCB circuit board machines and the chip making and stuff. That's all getting down to a level where you might be able to do it locally. And where I live in the San Francisco Bay Area, we're starting to experiment with this now. So for example, right now this girl's doing some surface mount work at one of our Fixit clinics. Okay? And what this might be leading to is a different type of a vision than what we have now with factories in China making our parts. It's possible that lots of things that right now are made in remote factories could be made locally using locally available tools, materials, processes, and services. So here's an example of this PCB maker from Canada that can print silver solder in lines fine enough that you can do surface mount boards with it. So certainly for prototyping, but if we move to a world where most things are sort of mass customization and manufacturing on demand, this sort of thing might become more the norm. And to me, that's great, okay? To me, that empowers little kids like this to be able to think about how they can have a future, where they are doing this stuff locally and sort of making resilient communities for themselves. Or for my seventh grader who can repair smartphones. So I'm going to close with this positive thought. So this is repair from the 15th century. This is kintsugi, the Japanese art of ceramic repair, where the repaired item is considered more beautiful and more valuable than the original. Is this something that we could try to attain in our civilization so that we have less of this and more of this? Thank you very much.